Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Good evening. Yeah, I think you must have had sufficient time to finish writing this proof in your notebook.
Yes, ma'am.
All right, children, fine. So we have to discuss from here. What about these children? You had time to work out all this in your book? So we finished this in the class, right?
Yes, ma'am.
Okay, okay. Yeah, let me just do this again for you. So here in this figure, we are given that OA. See here, this OA, this line segment OA is equal to the line segment OB. And this line segment OP, this one, this OP is equal to OQ, is equal to OQ. So what we have OA. Look at the figure. OA is equal to OB. Okay, let me clear this. Okay, so we have OA. Look at the line segment OA. OA is equal to OB. And also OP is equal to OQ. Now, subtracting these two, we can get a new result. What is that? What is OA minus OP? From the line segment OA, if you cut off the line segment OP, you will be left with what? PA or AP. It's like you erase it. You have the line segment OA. See, you have the line segment OA. Okay, let me draw it like this for you. Okay, so like from here to here is P. Okay, so what is this? OA. Now from this, see, I'll take away, I'll erase OP. From OA, see here, OA minus OP. From OA, this is the line segment OA. From this, we'll take away OP. We'll erase OP. See here, we erased OP. So you're left with AP or PA. That's what we've written here, AP or PA. Now, in the same way, we have the line segment OB. See here, OB minus OQ, OB. So how is OB? OB is like this. OB here. And we have Q on it. Okay, now what is OB minus OQ? So that means from the line segment OB, you are erasing or you're taking away the line segment OQ. So let's erase the line segment OQ. See here, I'm erasing from OB. I'm taking away, I'm not adding, I'm taking away, I'm subtracting. So that means you're erasing the line segment OQ. From OB, you're erasing or you're taking away the line segment OQ. You're not adding any line segment. You're erasing, you're taking away a line segment OQ. So now see, we're taking it off. So you're left with BQ. You're left with BQ. So that is what it is. So this is BQ. OB minus OQ is BQ. So this is a new result. From these two results given in the question, on subtracting these two, we can get a new result. AB is equal to BQ. AB is equal to BQ. So let's remember that. Okay, we have another result. AB is equal to BQ. AP, sorry, I said AB. AP is equal to BQ. We have another new result. All right. Now we have to prove that PX is equal to QX. PX is equal to QX. And AX, where is AX here? AX is equal to BX. Now, clearly, these two lines, these four line segments, okay, that is the line segments AX and PX, they are in the triangle APX, and the line segments BX and QX. BX and QX, they are in another triangle BQX. So clearly we have to prove to get these two results. To prove these two results, we have to take up these two triangles, show that they are congruent, and then by CPCT you can get the two results. Now, we understood in the last class that when we take up these two triangles, we do not have sufficient information to prove that they are congruent. Okay, so what is that we have in these two triangles? When you take up these two triangles, we have one pair of vertically opposite angles equal. This angle is equal. This angle of this triangle is equal to this angle of this triangle. Vertically opposite angles are equal. Okay, now as it is, we have to prove that QX is equal to AX. So we don't have that result. Okay, you have to prove that QX is equal to PX. We have to prove QX is equal to PX. And we also have to prove that, AX is equal to BX. So two equality is gone there only on the sides. Two pairs of sides equal, we don't have that, we have to prove. So which is the third pair? The third pair is BQ and PA. BQ and PA, that we know they are equal. See here, AP is equal to BQ, that we know, because on subtracting we got this result. I'll come once again. So we have to prove that PX is equal to QX, and we have to prove that BX is equal to AX. So that means we don't have these two equalities in these two triangles. We have to prove the third pair of equal sides are, meaning can be BQ and AP. BQ and AP. Yes, we have proved that BQ is equal to AP by subtracting these two. Okay, we know that BQ is equal to AP. So we have one information. BQ is equal to AP. BQ of this triangle is equal to AP of this triangle. Okay. Then one other information is this angle is equal to this angle. Vertically opposite angles are equal. Now we don't have another pair of equality. We don't have another pair of equality. Because we can't say alternate angles are equal, because we don't have parallel lines. So we don't know any other equality here. One pair of equal angles or equal sides we don't have. So what do we have here? Actually, we have only one pair of equal sides and one pair of equal angles. We don't have the third information, with which we can use a congruence rule and show that these two triangles are congruent. So what we have to do, we have to, take some of the two triangles and get an information, prove that they are congruent. And from the congruency of those two triangles, we need to get an information that will be helpful for us to complete this proof. So we take up these two triangles. That is why we take up these two triangles. We take up this triangle, and this triangle. We take up these two triangles. What are they? They are OPB and OQA. We take up these two triangles, and these two triangles are congruent because we know two equalities. Here OA is equal to OB. OA of this triangle is equal to OB of this triangle. It's given. It's given. OB of one triangle, OA of this triangle is equal to OB of this triangle. OP is equal to OQ. See here, OP of this triangle is equal to OQ of this triangle. Now we need another one. This is the common angle. Both the triangles have the same angle. See here, look at this triangle. See this triangle, it has this angle. The other triangle, this one, this triangle also has the same angle. So this is the common angle. This is the common angle. So side, angle, side. SA is congruence criterion. These two triangles are congruent. CPCT, we'll have this angle is equal to this angle. Now we'll use this information and complete the congruency. We'll say that these two, we'll prove that these two triangles are congruent. And it is when we take up these two small triangles, it is about this angle, this pair of angles, this pair, and then BQ is equal to AP. BQ is equal to AP. So it is not ASA, it is AAS. Two angles and some other side. Two angles and some other side. AAS congruence criterion, the triangles are congruent, and these results follow. All right, children?
Yes, ma'am.
All right. So we finished this in the last class, children. Now this one. In the given figure, ABCD is a square. Okay, so all sides are equal. P is a point inside it, inside the square, such that PB is equal to PD. PB is equal to PD. So PB is equal to PD. All right. Okay. Prove that CPA is a straight line. Prove that CPA is a straight line. So that means you need to prove that angle CPA is equal to 180 degrees. To prove that CPA is a straight line, you'll have to prove that angle CPA is 180 degrees. Here or here, anything. You can prove this one or this one. I'll tell you again. To prove that CPA is a straight line, you need to prove that angle CPA is equal to 180 degrees. Angle CPA is equal to 180 degrees because where do you find 180 degrees? It's a straight angle. It's found on straight line. Okay, so CPA, where is it angle CPA? See here, this one. This is the angle CPA, or this is the angle CPA. This is the angle CPA. Any one you can prove, any one of the two. You can either prove that the sum of, you can, if I mark the angles, 1 and 2, if I call this 1 and this one 2, I should prove that angle 1 plus angle 2 is equal to 180. So if angle 1 plus angle 2 is 180, not angle 1 is 180, angle 1 plus angle 2, the sum of angles 1 and 2, if it is 180, that means CPA is a straight line. Or I can also mark these angles 3 and 4, these two angles. Okay, or, okay, if you're not doing this, then you should do 3 plus 4. You must prove that 3 plus 4 is equal to 180 degrees. If you prove 3 plus 4 is 180, that means angle CPA is 180 degrees. Angle CPA is 180 degrees. So like this, we prove that CPA is a straight line. So that means, I don't know what I've taken here. Okay, I've finally proved 1 plus 3. All right, fine. Anything is fine. Anything is fine. So I've proved that 1 plus 3. I told you anything you can do. I've taken 1 plus 3. Okay, I've marked. I just want to explain it like this only. 1, 3, 2, and 4. All right. All right, children. Now, so that's the idea. So how to show that CPA is a straight line? To show that CPA is a straight line, I've changed the numbers, children, because I've marked it like this. So I've just changed the numbers, nothing else. So by this marking, I have to prove that 1 plus 3 is equal to 180 or 2 plus 4 is equal to 180. Very simple proof. Very, very simple proof. Now see here. Krishmika, tell us how do you show that these two triangles are congruent to each other? See, the proof goes like this, children. 1 second. It will go like this. You will have to take up these two triangles. Show that they are congruent to each other. So you will get angle 1 is equal to angle 2. Then take up these two triangles. Show that they are congruent to each other. So you will get the result angle 3 is equal to angle 4. Is it clear so far?
Yes, ma'am.
Very good. So we need to take up these two triangles. Which two? We need to take up this triangle and this triangle and show that they are congruent. That way we'll get angle 1 is equal to angle 2. And then take up these two triangles, show that they are congruent to each other, and we'll get angle 3 is equal to angle 4. Angle 4. Now we know that the sum of all the angles around the point is equal to 360 degrees. So the point is P. The point is P. There are 4 angles around the point P. There are 4. See, around a point, there can be as many angles. There's nothing that there can be, around a point, there can be 3 angles, 4 angles, 5 angles, 6 angles, any number of angles. It's not that there should be only 4 angles around a point. Here, there are 4 angles around the point P. In this figure, there are only 4 angles around the point P. So now we know that the sum of all the angles around a point is equal to 360 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360. This we don't have to prove. We know this result. The sum of all the angles around the point is equal to 360 degrees. Now you decide which you want to prove. If whether you want to show that 1 plus 3 is 180 or you want to show that 2 plus 4 is 180, that you have to decide. Okay, now suppose I have here done 1 plus 3. Okay, so I'll do 2 plus 4 here. I'll do 2 plus 4 here. So that means I want to write 2. Okay, and I want to write 4. I don't want 1 and 3. See here. See here. I want to write 2. I want 2. I want 4. I don't want 1 and 3. But we have proved that 1 is equal to 2. We have proved that 1 is equal to 2. So instead of 1, I can write 2. Plus, we have proved that angle 3 is equal to angle 4. So instead of 3, you can write 4. So now you have only 2 and 4. So twice of angle 2 plus twice of angle 4. That is like you say x plus x is 2x, right? Similarly, angle 2 plus angle 2 is 2 times angle 2. Angle 4 plus angle 4 is 2 times angle 4. Like you say x plus x is 2x. So 2 times angle 2 plus 2 times angle 4 is equal to 360 degrees. 2 common, angle 2 plus angle 4 is equal to 360 degrees. So angle 2 plus angle 4 is equal to 360 divided by 2, 180 degrees. And what is angle 1 plus angle 4? It's nothing but what is angle 2, children? Name angle 2. It is B angle.
Angle APB, ma'am.
APB. And name angle 4?
CBB, ma'am.
CPB, very good, CPB. So you're getting APB plus CPB is equal to 180. Now you know that the sum of these two angles together is angle CPA. This implies angle CPA is equal to 180 degrees. If angle CPA is equal to 180 degrees, this proves that CPA is a straight line. Isn't the proof, children, very simple, children?
Yes, ma'am.
Yeah, it's very easy proof. Now, Krishmika, you're going to tell me how to prove that these two triangles are congruent to each other. These two triangles. Yeah, quickly.
Yes, ma'am.
Yeah, in triangle.
In triangle APB
Yeah,
and triangle APD,
okay. Yeah,
BP is equal to PD, ma'am.
BP is of which triangle? Say,
APB,
no, say first triangle. This is the first triangle, this is the second triangle. Say first and second, okay? So BP of which triangle?
first triangle.
Is equal to?
PD of second triangle.
Tell me like that. BP, side BP of the first triangle is equal to the side PD of the second triangle. Okay, next. What's the reason? How do you know?
It's given, ma'am.
It's given. Okay, next. Yeah. Yeah, next, children. Oh, sorry, next, Rashmika.
Yes, ma'am.
Yeah, fast. It's all there. No problem, no problem. See, we'll either know or we'll learn. So both are good only. So don't worry. Yeah, now Raja, tell me.
Ma'am,
Yeah.
ma'am, AD is equal to AB.
AD of which triangle?
APD, ma'am.
I want the first triangle information first.
Sorry, ma'am. AB is equal to AD.
AB of the first triangle is equal to AD of the second triangle. How do you know?
Ma'am, because in a square, all the four sides are equal, ma'am.
Because ABCD is a square. Very good. And then one more.
Ma'am, AP is equal to AP.
Common side.
Yes.
All right. So what's the conference rule?
SSS.
Tell me the order. If I write triangle BAP is congruent to triangle.
BAP is congruent to triangle DAP, ma'am.
D.
AP.
Very good. By SSS rule. Okay. So CPCT, see, though, for those who've forgotten, I'll just tell you how to write it again. Children, take any two information. I've told you, take any two information. Say BP is equal to PD and AB is equal to AD. So now in this one, which is the common letter? B is the common letter. So write that letter like this. PBBA. I've told you this many times. PBBA. So it is PBA is equal to, here the common letter is D. So PDDA, like let it end with D. This is the common letter. See here, like this it should be the common letter. PDDA. So PDA. So PBA congruent to triangle PDA. So you can write it in different ways. If you write APB, if you write ABP reverse, you write ADP reverse, ADP. Okay, so here you see a P and P. P and P. P is equal to P. So how do you make out that? Angle P of the first triangle is equal to angle P of the second triangle. See, we have P in the same place. P in the same place. Angle P of the first triangle is equal to angle P of the second triangle. Now, which is the first triangle? This is the first triangle. Where is angle P there? Here, only this one is angle P. Inside the triangle, you must see. Inside the triangle, which is angle P? Only this one. Now look at the second triangle, which is angle P there. This is angle P there. This is angle P. These two angles are equal. And that is what we had marked. Angle 1 is equal to angle 2, or like this, angle 1 is equal to angle 2, whatever. That's what we had marked. Okay, Srijana. So CPCT, we have angle 1 is equal to angle 2. Yes, Srijana. Continue. Sindhu.
Ma'am, triangle BPC. CPD, ma'am.
Yeah. Yes, darling, faster.
Ma'am, BC is equal to CD, ma'am.
Come again.
Ma'am, CB is equal to CD, ma'am.
I think you said CB is equal to CD. Okay, then.
PD is equal to PB, ma'am.
PD is equal to PB. No, but you should say PB is equal to PD. Then
CP is common, ma'am.
very good. CP is a common side. CP is a common side. Correct. So CP is a common. Now, when you take up these two triangles, this is the common side. This side is equal to this side because all sides of a square are equal, and it's given that PD is equal to PB. So again, SSS rule, the triangle, the congruent. CPCT, you will have this angle is equal to this angle. That's all it is. And then you should use this. Sum of all the angles around a point is equal. Maybe you can write that. Sum of all angles. Sum of all angles around a point. Around a point is 360 degrees. Yeah. Yeah, children, any questions you have here? It's a very simple proof. If you're finding it difficult, please ask me now. Very, very simple. Okay, we are moving on. In the given figure, ABC is an equilateral triangle. Okay. ABC is an equilateral triangle. Okay. PQ is parallel to AC. PQ is parallel to AC. All right. And AC is produced to R. How many of you have written? I had shared some pictures. No, how many of you finished writing that in your book? Krishmika finished?
Yes, ma'am.
Sanjay and Sindhu?
Yes, ma'am.
Sridhana? Raja? Raja will ask us what? What, ma'am?
No,
What
ma'am.
we had to write?
No, ma'am.
Finished writing?
Not yet.
No, you did not write, is it?
Did not complete, ma'am.
Okay. Okay. Fine. In the given figure, ABC is an equilateral triangle. PQ is parallel to AC. PQ is parallel to AC, and AC is produced to R. AC, see, AC is produced to R. AC is produced to R. Okay, such that CR is equal to BP. CR is equal to BP. This one, CR, this one, the CR is equal to BP. CR is equal to BP. Okay, prove that QR bisects PC. Prove that QR bisects PC. QR, where is QR? This is QR. This is QR. Prove that QR bisects PC. Bisects PC is this one. See it. So this is PC. You must prove that QR bisects PC. That means what, children? What should you prove? Should we? Okay, I'll give you two options. Should you prove that M is the midpoint? Raja, tell me, should you prove that M is the midpoint of QR? Should you prove that M is the midpoint of QR, or should you prove that M is the midpoint of PC? Which is correct, or both are wrong? Are both correct, both incorrect, or which one is correct? Yeah, quickly.
Ma'am, PC, ma'am. We have to prove that M is the midpoint of PC, ma'am.
M is the midpoint of PC. Very good. We'll have to prove that M is the midpoint of PC because you'll have to prove that QR bisects. QR bisects which one? PC. That means PC is cut into two equal halves by QR. QR is not cut into two equal halves. Maybe. But what we have to prove is PC is bisected. That is PC is cut into two equal halves. In other words, we'll have to prove that M is the midpoint of PC. M is the midpoint of PC, or we'll have to prove that that means, not or, which means you'll have to prove that PM is equal to MC. So for this, Krishmika, which two triangles have you to take? To prove that PM is equal to MC, which two triangles have we to prove that they are congruent?
Sorry, ma'am, I didn't mute.
Yeah, tell me.
QPM and CRM, ma'am.
Correct. We'll have to take up QPM and CRM and show that they are congruent to each other. Just give me 2 minutes, children. I'm just getting a call. 2 minutes. I'll just come back. I'll just, shall I put you with another slide, children? Yeah, I think we'll not waste time. 1 minute. We finished writing till here. Yeah, do this one. 2 minutes. I'll get back to you. Yeah, thank you, children. We'll come back to this. I'm sorry to disturb you. We'll come back to this. Yeah. This one, correct. All right. So here, as we all understood, we'll have to prove that QR bisects PC. That is, M is the midpoint of PC. We'll have to prove that M is the midpoint of PC. Okay. Now again, so we all know that we have to take, to prove that PM is equal to MC, we'll have to take up this triangle and this triangle. Now let's find out what information we have in these two triangles to show that they are congruent. What do we have? We have one pair of vertically opposite angles equal. Yeah, okay. So this angle of this triangle is equal to this angle of this triangle. Vertically opposite angles are equal. And then see parallel line, transversal, parallel line. Parallel line, transversal, parallel line. Alternate interior angles are equal. So we have this angle equal to this angle. Alternate interior angles are equal. And I think that's all we have. We don't have any other information. You can think about that. So we don't have any other information. We have one pair of vertically opposite angles equal, and we also have one pair of alternate interior angles equal. So in the two triangles, we have two pairs of equal angles. That's all we have. We don't have any further information. So we cannot prove that they may be congruent, but we do not have sufficient information to prove that they are congruent. So we have to do something else and get an information that will help us complete the congruency in these two triangles. For that, what we do is, step one is, see here children, listen very carefully. ABC is equilateral. That means every angle is equal to 60 degrees. This is 60, this is 60, this is 60. Each angle is equal to 60 degrees because it's equilateral. Okay. So now using the concept of parallel lines, see here, extend this one. So we have parallel lines. You know that these two lines are parallel lines, and there's a transversal. This is the transversal. This is transversal. All right. Now we know about corresponding angles. No, not this one is not the transversal. Sorry, this is the transversal. This one is a transversal. This is also a transversal, children. This one is also a transversal. We are not making use of this transversal. That's all. This is also a transversal. What is a transversal? A transversal is a line that intersects two or more lines. That's all. When you have two or more lines, they need not be parallel. When you have two or more lines, and they are, when a line intersects, when lines intersect, not two or more lines like these lines are called the transversal. This is a transversal. This is also a transversal. So this one is a transversal. But we are not making use of this transversal. We are making use of this transversal. This one. So we have something like this. We have two parallel lines intersected by a transversal like this. So this angle is equal to this angle. Corresponding angles are equal. Now, how do corresponding angles lie? Let's recall. Corresponding angles, they are on the same side of the transversal. One is an interior angle, the other is an interior angle, but they should not form a linear pair. See here, children. Listen very carefully. Let's recall how to identify corresponding angles. Corresponding angles. Corresponding angles lie on the same side of the transversal. One angle is an interior angle, the other angle is an exterior angle, but these two angles, the exterior and interior angle, they do not form a linear pair. They should not form a linear pair. Now, for example, these are the four angles, angle 1, angle 2, angle 3, and angle 4. These are the four angles on one side of the transversal. Now, angle 1 and angle 4 are exterior angles. Angle 1 and angle 4 are exterior angles. Angle 2 and angle 3. Angle 2 and angle 3 are interior angles. Interior angles. Now, by the definition, corresponding angles are one pair of angles in which one is an interior angle, the other is an exterior angle, but they should lie on the same side of the transversal. So we take angle 1 and angle 3. You cannot take angle 1 and angle 2 because you can say one is exterior, 2 is interior. Why not take 1 and 2? But 1 and 2 form a linear pair. So you should not take 1 and 2. Corresponding angles lie on the same side of the transversal. One angle is an interior angle, the other angle is an exterior angle. But these two angles must not form a linear pair. That's the important condition. They should not form a linear pair. So you can take 1 and 2. 1 is exterior, 2 is interior. But 1 and 2 form a linear pair. So they are not corresponding angles. That is why we should take 1 and 3. They lie on the same side of the transversal. 1 is an exterior angle, 3 is an interior angle. So 1 and 3 form a pair of corresponding angles. Similarly, angle 2 and angle 4. One is interior, the other is exterior, and they lie on the same side of the transversal. They don't form a linear pair. You cannot take 4 and 3. 4 is exterior, 3 is interior. But they form a linear pair, so you cannot take 4 and 3. Am I clear, children?
Yes, ma'am.
Okay. Now, use the same idea. Okay, so this is the transversal. This one is the transversal. Parallel line. So these two lines are parallel to each other. It's given. It's given. This is the transversal. So look at the transversal very carefully. This is the transversal because these lines are disturbing. No, in the middle, this is disturbing. See, I'm getting disturbed. I'm getting disturbed by this. Okay. Now we know that this angle is 60 degrees because it's an equilateral triangle. So this angle is 60 degrees. Now corresponding angles are equal. So see here, is 60 an interior angle or an exterior angle, children? Okay, on the transversal, let me mark all the 4 angles, children. I'm sure this is confusing. Let me mark all the 4 angles. 1 minute, 1 minute. Let me do that. Can you all make out the 2 parallel lines and the transversal? Is that part clear? The 2 lines, parallel lines and the transversal. Is that part clear?
Yes, ma'am.
Yes, ma'am.
Now, on one side of the transversal, we'll have 4 angles, correct?
Yes, ma'am.
Okay, let me mark those 4 angles. I'm marking the angles. This is angle 1. This is angle 2. This is angle 3. This is angle 4. I have marked all the 4 angles on one side of the transversal. Yes or no? Have I marked everything? To say yes or no, it takes this long, is it? Have I marked everything?
Yes, ma'am. On one side of the transversal, you have.
Yeah. Now tell me the 2 interior angles.
Ma'am, angle 2 and angle 3.
Thank you. Exterior angles?
Angle 1 and angle 4.
Angle 1 and angle 4. Now choose. Take one interior and one exterior angle, but they should not form a linear pair. You should not take 1 and 2. That's a linear pair. Now tell me the 2 pairs of corresponding angles. You will have only 2 pairs of corresponding angles on one side of the transversal. On one side of the transversal, you will have only 2 pairs of corresponding angles. Tell me. Which are the 2 pairs?
Angle 3, ma'am.
Angle 1 and angle 3, then?
Angle 2 and angle 4, ma'am.
Angle 2 and angle 4. Angle 1 is exterior, 2 is, 1 is exterior, 3 is interior, 2 is interior, 4 is exterior. Is this clear to all of you?
Yes, ma'am.
Now, what is the measure of 3? 60 degrees.
Yes, ma'am.
Because equilateral triangle. Then what is the measure of angle 1? 60 degrees.
Degree, ma'am.
That's what I was telling. That is what I'm saying. This is exactly what I'm saying. So here, what is important? What was important here, children? That basics as to how to identify corresponding angles. Now, without, see, without telling you that if I say, supposing you say you don't understand, and I'm like going on telling you, see, yeah, this and this are corresponding. Can't you make out? Can't you make out? That's incorrect. That's not the way I should be telling you. Can't you make out this and this are corresponding angles? Haven't we studied in 7th standard? No, that's not an answer to your question. When you say that you're not able to identify the corresponding angles, I have to go back to the basics. How to identify corresponding angles? So corresponding angles, they lie on the same side of the transversal. On one side of the transversal, you'll have 2 pairs of corresponding angles. And corresponding angles are one interior and one exterior angle, but they should not form a linear pair. So like that, if you use these basics and then try to identify, it's so clear. So we should identify the parallel lines, the transversal. So these are the two parallel lines. This is the transversal. So these angles are formed. These angles are there on one side of the transversal. Exterior, interior, exterior, interior. Oh, sorry. Exterior, interior, interior, exterior. So this exterior angle and this interior angle, corresponding angles. This interior angle and this exterior angle, corresponding angles. Yeah, now we have understood. Let's come back to this. So you should extend and all that and see. So this angle is 60 degrees. So this angle is also 60 degrees. Corresponding angles are equal. Now we already know that this angle is 60 degrees because ABC is an equilateral triangle. So this is already 60 degrees. So by angle sum property, QBP in triangle QBP, this angle Q is also 60 degrees. Yes or no, children?
Yes, ma'am.
So what do you call triangle QPB? What special name can you give to triangle QPB?
Equilateral triangle, ma'am.
It's an equilateral triangle. That means all the
equal.
sides are equal. All the sides are equal. That means all the sides are equal. Now we know that this side is equal to this side is equal to this side. But we are given one special information. CR is equal to BP. Where is CR? This is CR. Oh, okay. Let's number. Let's take some measure. So this is 4 centimeters. This is 4 centimeters. This is 4 centimeters. Okay. The equilateral triangle has each side equal to 4 centimeter. Now see this information here. CR is equal to BP. Oh, this BP and CR, they're equal. That means CR is also 4 centimeter, right?
Yes, ma'am.
So
Yes.
that means QP is equal to CR, correct? Length.
Yes.
The length of the line segment QP is equal to the length of the line segment QR.
Yes.
Yeah. Now, how do you present that? So why are we doing this? Now so that way we can get the information. QP of this small triangle is equal to CR of this small triangle. That's why we are doing all this. That is why we are doing all this. So we'll get QP of the small triangle is equal to CR of this triangle. And that way we can complete the congruency. Because we already have two pairs of equal angles. We just want one more information. So how do you present that? So you must write CR is equal to BP given. Here, CR is equal to BP given, which is CR, this is CR, is equal to BP given. But BP is equal to QP, right? BP is equal to QP. So you should make out from the way I'm writing. CR is equal to BP given. CR is equal to BP given. But this BP is equal to, it's equal to QB, but that we don't want. So it's equal to QP. It's equal to QP. BP is equal to QP. So when you compare these two, we get CR is equal to QP. CR is equal to QP. CR is equal to QP. Now when these two triangles, this triangle and this triangle, vertically opposite angles are equal, alternate interior angles, I already showed you that alternate interior angles are equal, and then QP is equal to CR. So what's the congruence rule, children? What's the congruence rule, children?
Yes, ma'am.
Yes. Yes.
Children, please. How do you have two sides here? How do you have SAS here, children? See here. Alternate interior angles are equal, vertically opposite angles are equal, and this side is equal to this side.
Yes, ma'am.
AAS. AAS. I'm sure it was, like just by mistake. I'm sure. See, you all understand that this angle is equal to this angle. Alternate interior angles are equal. See, a parallel line, transversal parallel line. Alternate interior angles are equal. And then vertically opposite angles are equal. And then we got this information. QP is equal to CR. QP of this triangle is equal to CR of this triangle. We have taken these two small triangles. See, this one and this one. So AAS congruence rule, the two triangles are congruent. CPCT, we have PM is equal to CM. PM of this triangle is equal to CM of this triangle, which means QR bisects PC. That's what is here, children. Proofs, it's difficult to, I can't, if I read, no, then it's difficult for me. That's why I'm not using this. The same thing is here. What I just said is what is here. Let me also just see it once. QR bisects. You can also go through the proof. You can make a transversal BC, children. Maybe I typed it like that. Transversal BC. BC is also okay, but you can make it BC with the lines QP and AR. With the lines QP, and you can make this AR. One minute, I'll just children, this point, see, anyways, you have to work it again to just 1 minute. Children, anyways, you will have to work and practice. So you can just make this, strike it with a pencil and, write it like this so that you can understand better. ACB is equal to 60 degrees. I think this part, I just want to write it in a better way. This part. You can just, this part, I'll just write it here for you. AR is parallel to QP. And BC is the transversal. BC is the transversal. Okay. Angle AC, ACB is equal to angle QPB. Corresponding angles. ACB is equal to 60 degrees. Because ABC is equilateral. Therefore, QPB is also 60 degrees. You can just make it like this, children. The story, instead of this, same information, I'm just putting it in a different way. AR is parallel to QP. BC is the transversal. ACB is equal to QPB, corresponding angles. But ACB is 60 degrees. So QPB is also 60 degrees. I think this is better. Yeah, children. All right, children.
Yes, ma'am.
Yeah. Then in triangle QBP, angle B is 60 degrees, P is 60 and Q is 60. How do I write this directly? Okay, I've written implies. Okay, QPB is equilateral. Here also, okay, let me do one thing, children. I'll just make this in a more friendly way. The proof is correct. I know you understand that. The proof is correct, but I'll just present it in a, more friendly or more, convenient way so that you can understand easily. Whatever I just explained, I'll just correct the slide and resend it to you on WhatsApp. Okay, let's not waste time now. You understood the proof, children, when I explained?
Yes.
Yes, ma'am.
Yeah, this proof which you see is correct, but it's not very friendly. It's like looks very complicated. I'll present it in a better way and share the answer with you on WhatsApp. Yeah. All right. In the given figure, the bisectors of in the given figure, the bisectors of angle B and angle C of triangle ABC. Bisectors means what here? Bisectors of angle B and angle C. Which is the bisector of angle B? Which one is the bisector of angle B? Name the bisector of angle B. Name the bisector of angle C.
BI.
BI, very good. BI, very good. Which is the
Bisects angle B, it
yeah,
bisects BI, and angle C is bisected by CI.
correct. BI bisects angle B. CI bisects angle C. Now, Raja, if I say this is 70 degrees, what can you further conclude? And if I say this is 60 degrees, what will be your further conclusions? Which angle is 70 degrees?
Angle B, ma'am.
Tell me using 3 letters.
Ma'am, angle RBP is equal to 70 degrees.
Very good.
And
If very good. No, if RBP is equal to 70 degrees, what can you further conclude? This implies angle
implies
RBI is equal to
RBI is equal to 35 degrees.
and angle
IBP is equal to also 35 degrees.
yeah PBI is also equal to 35 degrees.
35
In the now which is 60 degrees? Name the angle which is 60 degrees.
Angle C, ma'am.
3 letters.
ACB.
ACB. Yeah,
sorry,
correct.
QC.
Yeah,
QC.
ACB is correct. ACB is correct. Or you can also say QCP is 60 degrees. So which are the two equal parts? Okay,
QC.
1 minute. Krishmika, which are the two equal parts? Yeah. If angle QCP is 60 degrees, we know that CI bisects angle QCP. Srijana, which are the two equal parts? Sanjay?
Ma'am, ma'am, QCI, ma'am, QCI equals to 30 degree and ICP equals to 30 degrees, ma'am.
QCI is 30 and then angle?
ICP, ma'am.
CPI, yeah?
ICP, ma'am.
IPC?
ICP, ma'am. 30 degrees, ma'am.
Very good. Angle QCI and ICP is equal to 30 degrees or PCI is equal to 30 degrees. Very good. So that is what is the meaning of what is that? The bisectors of angle C, B and C meet at I. The angles are bisected. This angle is divided into two equal angles. This angle is also divided into two equal angles. This line segment BI bisects this angle, and this line segment CI bisects this angle. So these two portions are equal. Now, IQ is perpendicular to CA. Okay, sorry. IP is perpendicular to BC. You can see here, IP is perpendicular to BC. IQ perpendicular to CA. IQ is perpendicular to CA. All that is given to you. And IR is perpendicular to AB. All this is given to you, children. So much of information we have. Okay. So we have perpendiculars and we have bisectors also of these two angles. Now with this, we'll have to prove that IP is equal to IQ is equal to IR. You need to prove that this is equal to this is equal to this. All the three at the same time we cannot prove. We know that at a time we can take only two triangles and prove that they are congruent. So at a time you will get only two things. Like maybe you will get IP is equal to IQ. You cannot prove everything at the same time. So first you will show, say IP is equal to IQ. Then you will show that IQ is equal to IR. Then like you will say, show that A is equal to B. Then you will show that B is equal to C. So A, B, C are equal like that. Yeah. Then finally you must prove that IA bisects angle A. IA or AI bisects angle A. So angle A is not bisected. You must prove that it's bisected by AI. Like VI bisects this angle, CI bisects this angle. You must prove that AI or IA bisects angle A. So we are given these angles are equal 90 degrees, 90 degrees, 90 degrees. We should prove that this angle is equal to this angle. And we must prove that IP is equal to IQ is equal to IR. Are the details clear, children?
Yes, ma'am.
Yeah. Now, as we understood, you cannot show this at the same time. So you must do it one by one. So first, maybe you can say that IP is equal to IQ. You'll have to take two triangles. You'll have to take two triangles, show that, they are congruent and prove IP is equal to IQ. Then two other triangles, show that whatever IQ is equal to IR. Only when we start working, we'll know. Then like this. So like this, A is equal to B, B is equal to C. So A, B, C, they're equal. So first, let's try to prove that IP is equal to IQ. IP is equal to IQ. So IP and IQ. See, you should take two triangles. One triangle should have IP, the other triangle should have IQ. Tell me, which triangles will you take?
Ma'am, IPC and IQC.
IPC and IQC. Very good. We'll have to take up these two triangles. We'll have to take up these two triangles. IPC, IQC, because IPC has IP, IQC has IQ. Yeah. Now tell me, Raja, what information is available?
Ma'am, angle P.
IPC, IP, IQC. 1 minute, 1 minute. IPC, IQC. We are taking up this triangle and this triangle, these two triangles, this one and this one. Because this has IP, this is IQ. Yes, Raja.
Ma'am, angle P in the triangle IPC is equal to the angle Q in the triangle IQC.
Correct. So if I number it angle, okay, angle IPC is equal to angle IQC is equal to 90 degrees given. Correct. Next.
Angle IC is equal to angle IC. Common side.
Angle IC, yeah?
Sorry, IC is equal to IC. Sorry.
IC is equal to IC, common side. IC is equal to IC, common side. Very good. Next one.
Angle QCI is equal to angle PCI.
Very good. Angle PCI is equal to angle QCI because angle C is bisected. PCI is equal to QCI because the angle is bisected. We don't know what they measure, but they are equal. Very good. What's the congruence rule? Because there is a 90 degrees, it's not RHS. Because it's 90 degrees, it's not RHS. Yeah. What rule? Anybody can answer this? What rule?
Yes, ma'am.
AAS. Very good. AA. Two angles and some other side. Two angles and some other side. See this angle, and some other side. I see. Because this is the included side. And then this angle, and some other side. I see. So by AAS rule, the two triangles are congruent. So CPCT, what will, so name the triangles in the correct order. In the correct order, you will get. Now see, the equal angles are P and C, no? So you can say, if you say PCI in the first triangle, P is Q there, C is C only, QCI. So you can clearly see that PI is equal to QI. So the first part we proved. We proved the first part. IP is equal to IQ. We proved this. Isn't that easy, children? Everything is given. We did nothing. We are just, writing out whatever is given. That's all. And then choosing a congruence rule according to the information we have written. Nothing else we have done. Okay. Now, take up another triangle. Now we proved that IP is equal to IQ. Now you can choose. Whatever is meaning, choose meaning you don't have choices, but what is the other thing you can take?
Ma'am, triangle IQA is equal, IQA and triangle IRA.
IQA and IRA. Okay, try. See, I'll tell you one thing. Where is the information given? Now we have used angle C, no, because it's bisected. See, you should use portions where we have information. Now you used, Raja, you used angle C is bisected. So you had an information. Half of the angles are equal. Which is the other information given? Okay, children, see now the two triangles which we took, now we took up these two triangles. So we could use the information given. See, you need information to prove that the triangles are congruent. So we use this one. Angle C is bisected. Now what other angle is bisected? Which is the other angle bisected? It's given in the question. Which is the other angle bisected?
Angle Q and angle.
That's why I explained what information is given. You all said you understood. Which are the two angles that are bisected?
Angle B and angle C now.
Angle B and angle C. Now we took up these two triangles, right? So there we use this information. Angle C is bisected. Didn't we say that this angle is equal to this angle? PCI is equal to QCI. Now, which is the other angle which is bisected? Angle?
Angle RBP or angle B, ma'am.
I don't know. I don't understand. Very simple. Angle C is bisected. Which is the other angle which is bisected?
Angle B, ma'am.
Angle B. Angle B is bisected. Angle B is bisected. See, you have to, you're leaving the portion where you have information, and we are going to some portion where we don't have any information. See, now angle B is bisected is given, right? So which two triangles should you take?
Ma'am, triangle IRB and triangle IBD, ma'am.
Yeah, when you take these two triangles, what can you prove? Finally, what can you prove? What is equal to what?
IR is equal to
IR equals to IP, ma'am.
IR is equal to IP. We already proved that IP is equal to IQ. We already proved that IP is equal to IQ. Now, using these two triangles, you can prove that IP is equal to IR. IP is equal, it's like A is equal to B, A is equal to C. So A, B, C are equal. A is equal to B. A is also equal to C. That means A, B, C are equal. IP is equal to IQ. IP is also equal to IR. So that means IP, IQ, IR all are equal. So again, we need to keep in mind what information is given, and we should take select triangles so that we can use the information. So now you need this angle is bisected. So let's take up these two triangles. Yeah. Yeah. Anybody can try.
Ma'am, can I?
Yeah. Tell me. So these two triangles. These two triangles. Yes,
Yes,
in
ma'am.
triangle.
In triangle IRB and IPB.
IB cube, IBP, yeah.
Angle IPB is equal to angle IRB.
Okay, so because I've written this triangle first, I'll write angle IRB. Okay, let me number it to be more. Uh, 1, 2, 3, 4, 5, 6. Raja, please use a number so that all of us can understand.
Yes, ma'am.
Yeah.
Angle 1 is equal to angle 2.
Measure?
Measure
Equal to?
90 degrees.
Okay.
Angle 5 is equal to angle 6 because it bisects angle B.
It bisects means who bisects?
Sorry, ma'am. IB bisects angle B.
Because IB bisects angle B. Very good. Next.
Then IB is equal to IB because it's common side.
IB is equal to IB, common side. So again, the same congruence rule. Two angles and some other side. So AAS rule. Thank you, Raja. AAS congruence rule. The two triangles are congruent. CP, we have IP is equal to IR. IP is equal to IR. Now we have successfully proved the first part. That is, IP is equal to IQ is equal to IR. Now we have to prove that IA bisects angle A. IA bisects angle A, which means you should prove that this angle is equal to this angle. You must prove this is equal to this. Now for this, we'll have to take up these two triangles. Yeah, anybody can tell me?
Ma'am, shall I?
Yes.
Ma'am, angle 9 is equal to angle 10, ma'am, which is 90 degrees.
No. 1 minute. I've not still marked the angles. 1 minute. Yeah. Yes, Krishmika, please.
Yes, ma'am.
In triangle?
In triangle IRA
Yeah.
and IQA.
Okay.
Angle 9 is equal to angle 10, ma'am, which is 90 degrees.
No, ma. 9 is not equal to 10, darling.
Ma'am, angle 5 equals angle 8, ma'am.
Angle 5 is equal to angle 8. Correct. Angle 5 is 90 degrees. Angle 8 is also 90 degrees. Very good. Okay.
Ma'am, AI is common, ma'am.
AI is common. AI is common. AI is equal to AI common. Very good. Next.
Ma'am, IR equals to IQ proved, ma'am.
Very good. Yes. IR is equal to IQ proved. IR is equal to IQ. It's proved. IR of the first triangle. IR is equal to IQ. Very good. IR is equal to IQ. We proved no, IP, IQ, IR all are equal. So we use that information. IR is equal to IQ. Very good. So what's the congruence rule here? Yes, children, what's the congruence rule?
RHS, ma'am.
RHS. Very good. It's RHS here. 1 second. I'm just sending a message. Just a second. Yeah. So the rule is RHS because this is the right angle. AI is the common side, which is the hypotenuse. And this is some other side. 5 is equal to 8, right angle, R. AI is the hypotenuse to both the triangles. AI is the side opposite of the right angles in the two triangles. So it's a common hypotenuse. And some other side, IR is equal to, 1 second. Yeah, sorry. Yeah. Yeah, I was telling you that right angle and then hypotenuse. It's a common hypotenuse. AI is the hypotenuse to both the triangles. And IR is equal to IQ. Some other side, RHS. The two triangles are congruent. So CPCT, you will get angle 6 is equal to angle 7. CPCT angle 6 is equal to angle 7. So if 6 is equal to 7, that means AI bisects angle A or IA bisects angle A. Because 6 and 7, they're equal portions of angle A. That means AI or IA bisects angle A. Was it okay, children?
Yes, ma'am.
All right, children. I'll share some more images on WhatsApp. Please complete that. Saturday, we will not have a class. Diwali is on Monday, but some of you might be going to your native town, whatever. So Saturday will not have a class, but I'm just giving you some work. So I will send the images on congruent triangle so that you can at least complete that in your notebook. And we'll discuss the proofs in the next class on Tuesday. Tuesday we'll have a regular class. Saturday, no class on account of Diwali. All right. Please complete the homework, children. Some of you have not written the proofs. Please, Raja, not completed, you said. Please complete it. All right.
Yes, ma'am.
All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you, children. Thank you.